In this video, we're gonna cover 3 common ways to make if conditions in Bash and give some real-world examples that most new Bash programmers are searching for. That will help you know when to use single brackets, double brackets, and double parentheses, and also the tools to make more complicated conditions. Hey, it's Newling here from Stacks Add Up, where I help you learn the technology stacks more efficiently with online video. If you're new here, make sure you click that subscribe button. And if you're seeing value in this video, give me a thumbs up as well. It really makes a huge difference. You can find all the links to everything I mentioned in this video in the description box below. Let's jump into it. I will break the content into 3 parts. The first is getting to know what we can do with if, so that you can have the big picture of this tool. Next comes the syntax, introducing the key elements to make an if statement. And then it's examples. You'll see some usual ways to use if conditions to solve problems. The first we're gonna see is the usage of if. The if statement is a tool that we can use to control whether to run a block of code by giving a test command. A test command could be the execution result of Linux commands, checking the existence of files or directories, the string or number comparison, etc. I have here 2 examples for you to get this idea. In the first example, you can imagine a situation when we need to do some cleanup before the main operations. So we can use if with the test command -e to see whether the target file has been there or not. If yes, we'll remove it first by using the rn command. If not, we'll skip this block of codes. Then, in the next block, we re-download that file. Again, don't worry about the syntax now. I'll introduce it soon in the next section. In the second example, we're testing if the current user has the right to update the package index. If the user ID is equal to 0, which means he's the root user, then we'll do the update. If not, we'll print a message to inform them. So now you have some general ideas about what if can do. Next, let's get into the syntax. The syntax of if contains 3 major parts: input, 0, and the non-zero. For input, Bash needs you to give it commands or expressions to evaluate, and then Bash will decide whether to execute the code block inside it according to the value of the evaluation result. If the value is 0, which means true or successful, Bash will run the body part. Otherwise, the non-zero value means false or failure, and then Bash will fall through to another test commands or continue to the rest of the codes. Okay, let's see some more details about how to make an if statement. First is the input. Sometimes we might have some codes to be run only if a set of commands is a success. That's the time when we take Linux commands or other third-party programs to make a test command. Most of the time, we will do some comparisons first, such as strings or numbers comparison. And if that comparison is a success, we then run the codes. So we'll use conditional or arithmetic expressions to do that. And there's another situation when we need to make sure the program stays, so we check certain variables or flags. If they are in the conditions as we expect, running the rest of codes is safe. So these are the when and why we make test commands. The next one is the 0 part. We put all the codes here when the values or states are as we expect. On the non-zero part, usually there are situations on the other hand. So we prepare some actions to deal with them. Or we can just do nothing if there are no particular actions to take. Now, we're going to see the actual syntax of if. By the way, there are 3 forms we can choose from. The first one is the simplest. First, we write down the keyword if, and then 1 or more test commands. We'll show you all the types of test commands in the example section. After that, we need to put a comma, then a space, then the keyword then. Now comes the body part. Here is the place we run procedures when the above condition is true. In the end, we put a very weird keyword fi. It's the reverse of if to end this if statement. The second form is an additional part between the if command and the fi keyword. It starts with the keyword else. Then you can put the commands which will be run when the above condition is false. Usually, when we have 2 blocks of codes that will run in different situations, we would choose a more common one and set it as if commands, and then design a test commands for it. Then we set the less common one as else commands. The third form is often used when you have multiple conditions to match. That is, you have code blocks to be run in at least 3 different situations. This kind of form adds another part between the if command and the else keyword. It starts with the keyword ELIF, which means else if. Then again, you can put the codes here belonging to this condition. The next up is the examples. I'll show you 3 ways to make the test commands, including using the Linux command directly using conditional and arithmetic expressions. All the example files shown here can be found on my GitHub repository. You can find the link in the description box below. Let's go! Let's say we have some commands which will need special privileges to run with, such as tcpdump, a program that can print out the content of network packets. Typically, this program will need a high privilege, such as superuser level, to run it. So we want to test if we have enough privilege first. If yes, we can then continue with that program. If not, we may need to inform users of other ways to do the same thing. So now, it's time to write some real codes. Here we type the if keyword first, then the program name tcpdump. Then, because we just want to test our privileges here, not capture all the packets, we give an option -c and 1 to tell the program to stop after capturing one packet. After that is the special syntax of bash, which means dropping all the possible outputs and error messages since we don't need them. If you're interested in this feature, please let me know by leaving comments below. Next, a comma, a then keyword, followed by the body part, just as we've mentioned before. Here we print a message to tell users that they have the right to invoke tcpdump. But of course, you can put any other commands to handle your business logic instead. We also write down an else keyword for the case when the login account doesn't have enough rights. Here we go, let's test our script. But before we start testing, I'm gonna use another program, whoami, to show the login name. So you can see now, I'm logging as my name, Neil. Let's run the script now. As we expect, I'm not a super user, so the message says I don't have the privilege. Now I'm changing to root user and run the whoami again. Yes, I'm root now. Then run the script. And yes, it says that we can start to capture packets now. The second way to make test commands is using conditional expressions. We often use it to check the existence of files or directories or do string comparisons. Today we're going to see the later one, the string comparison. There are 2 types when making this kind of expression. One is using the single bracket version and the other is using the 2 brackets version. Unless you're dealing with an old bash version, please take the 2 brackets version instead because it's newer and easier. It looks like this. Assume we're running a service with different customer classes, and we treat them differently according to their class. So the first step when a customer comes is to identify their class. Let's say we now have a customer called Jack, who is in Go class, and we want to do something special for this class. So here's the code. First, we assign Jack to the name variable and got his class in a class variable. And we start writing the if statement. First is the if keyword, then the double left brackets, and the variable class. The double equal sign is used to test if his class equals the Go string. After that is the double right brackets, the comma, and of course the then keyword. In the body part, we can perform a special process for golden customers. Here we just print his information out. And finally is the fy keyword. Let's run this script now. Because the Jack's class is just the same as gold, his information is printed out as we expected. But what will happen if we, for some reason, decide to downgrade his class to silver? Let's try it. We are changing the class variable to silver and rerun the script. This time nothing happened since the silver did not pass the test. The third way to make test commands is using arithmetic expressions. We use this form to do number comparisons. It's like conditional expressions but using 2 parentheses instead. You can use a conditional expression to compare numbers, though using this form would be much easier. Let's jump into an example to see how this works. Let's say we're writing a script to process student scores. Our goal is to show whether they are passing the tests or not. The pass criteria is the total score needs to be greater than 180. And assume we have one student score like this. Math is 50, language is 75, and science is 69. The first step is to calculate the total. We use a feature named arithmetic expansion to do this. So we put a variable total to hold that value. Then the syntax of arithmetic expansion. A $sign to parentheses, then the addition of those scores. And then a close parentheses. We do not hurry to write the if statement yet. Instead, let's check the adding result. If something went wrong at this point, it would take much less time to debug. So we print the total value out. And it's 194. So far, everything is okay. Then we can delete the echo line and start writing our if statement. First, we have the if keyword and two open parentheses. Following that is the test command. We put the test to see if the total variable is greater than 180. And then the two close parentheses. The rest is just the same as we mentioned in the syntax section. So we print the pass string in the zero part, which means the test is a success. And on the other hand, print the failed one in the non-zero part. Now let's run the script. And it printed the pass because the score is 194 greater than 180. And now let's change the language score to 60. Then the total score will be 179. So the output will be failed. That's all the 3 ways to make test commands. Did you get it? But we're not finished yet. I have here 2 bonus examples for you. One is multiple conditions. Sometimes simple conditions are not enough. We need more tools like logical AND, logical OR, else if, and else to construct more complicated ones. Next is not condition. Sometimes we just want something else. However, it may be hard to use normal conditions to do so. Bash provides an operator called logical negation for this purpose. I'll show you how to do them on the following pages. Let's first see the multiple conditions example. Sometimes we might have more than one condition to define different states. Take childhood as an example. It can be roughly seen as these stages: baby, toddler, and child. Babies' ages are under 12 months. Toddlers are between 12 and 36 months. And children are greater than 3-year-old. So just simple greater than or less than is not enough. We need to handle this situation more precisely. Okay, so I put the ages and stages criteria in the comment above. And we put the first line to set the age variable. But wait, hold on a second. What if we got an age that doesn't fall within all the above ranges? What would our script go? Most of the time, our codes would go in a high uncertainty state. That's not the case we want. But we can avoid it in the very early stage by validating the data, the age variable. So we start writing an if statement, and remember, we're dealing with numbers, so use 2 parentheses. Then the conditions, if the age is less than 0. We humans' age cannot be below 0, right? And followed by 2 vertical bars, which means or, then another condition. If the age is greater than 144, the age of a child becomes a teen. In the body part, we simply print an error message and exit the script to avoid any possible problems. If the age variable can pass this test, we can say it's safe to run the rest of the codes. Now we can write the statements for the main logic. Let's first handle the baby by starting with the if keyword, 2 parentheses, a condition age less than 12. Then in the body part, we print out its category, baby. Next comes toddler by using the keyword else if. The condition would be age greater than or equal to 12, and followed by two and symbol. And then age less than 36. And again, show its category, toddler. Finally is the child, so we put it in the else part. Its condition is implicit, which is age greater than or equal to 36. You can play around this script by changing the age variable to see how it works. So in this example, we not only saw the usage of else if and else, but also multiple conditions by using logical AND and logical OR. These tools can help you make lots of complicated test commands. Okay, the second bonus example is not condition. Often, our scripts need to run under certain preconditions. Therefore, we have to check whether that precondition is fulfilled before continuing. Take this web application as an example. The file app.py is working under the directory project/webapp. So one of the preconditions is that the directory needs to be there first. Let's write a simple script to make this happen. First, we set the project path variable to ./project/webapp as the working directory. Then the test commands. Here we use an option -d to test whether a given directory exists or not. In the body part, we just temporarily print a short message to show that the directory exists. Now let's test this part of the code. Because we don't have any directory yet, of course our script won't output any message. So by making that directory structure, our script will print exist as we expect. Now let's clean up what we've just done. And this time, we add an exclamation mark and change the output message. Then we rerun the script. Yes, it shows not exist. After making sure our logic is correct, we can now write the actual code. First, we print out a formal message to say we are about to create that directory structure. The following line calls the makedir program to do that job. And then when it's finished, we show another message to inform users that the initialization is done. Then the script can continue its business logic. Okay, let's review what we have learned today. We now know if is a tool for switching on or switching off a section of codes according to the test command result. The test command could be Linux commands, files or directory existence testing, or string or number comparison. The key element of the if syntax is to make a test command as its input. The test result either is 0 or non-zero. The codes in the body part will be executed when the result is 0, while non-zero might cause another test command evaluation or just fall through to the rest of the codes. And then, I showed you some real examples that are the common ways to make test commands, including using Linux commands, conditional expressions, and arithmetic expressions. And two bonus examples to teach you to make even more complicated conditions. Hope all these materials can help you understand that there are so many possibilities that if can make. Do you feel that you got a lot of value out of this video? If so, what did you get out of it? Please leave a comment below and let me know what you think. Now, if you're interested in checking out more tips as well, Then I put together a PDF guide that is linked in the description box below. This runs through the most common questions that can help you save time on debugging and spend more time creating values. Make sure you're grabbing your free copy of my guide, and I'll see you in the next video. Happy stacking!